Okay, so we're going to start the next chapter on surface area and volume, and then after the lesson, you guys are going to write your chapter 1 quiz. So we're going to be talking about surface area, volume. We're going to be talking about different shapes, cylinders, prisms, cones, spheres. And in those, there's some terms we're going to look at. The lateral area, the slant height, the apex. So those are some of the things that we'll be looking at. So we started with measurement in this unit. Now we're going to do surface area and volume. And then at the end, we'll do trigonometry. That's chapter 3. And then after that will be your last exam. So we'll start by reviewing some formulas for area. That first shape is a triangle. And the formula for area of a triangle is 1/2 base times height. If you multiply the 1 on top by the b and h, and multiply the 2 on the bottom by 1 times 1, because this is b over 1 and h over 1, another way of looking at this formula, you can say it's just base times height divided by 2. So that's the formula for area of a triangle. A rectangle is length times width. For a square, if we consider each side of the square to be s, and a square is like a rectangle, you're going to multiply the base times the height, or the length times the width, only now it's s times s, which is s squared. And the formula for area of a circle is pi times r squared. So pi is approximately 3.14. It's actually an irrational number. It goes on forever, doesn't repeat, doesn't terminate. Most calculators have a pi button on them, and that's what we will use. We will round off our final answers, not answers that we get as we're working through a problem. So those are some of the formulas we're going to be using, and they are on your formula sheet. So I know, Cherry, you went here to get this, so you can come and grab a formula sheet. We started using this one last week when we worked with metric and imperial measurements. Come get. Now we're going to start using some of the other formulas on this sheet. In the middle on the left-hand side, you'll see 5 formulas. The first one's C of circle. That's circumference of a circle. We used that in the last chapter. Then A of triangle, area of a triangle, 1/2 base times height. Area of a square is s squared. Area of a rectangle, length times width. Area of a circle, pi r squared. So these are the same formulas that we just looked at. So you'll have that formula sheet for any quizzes or tests. You don't have to memorize any of these formulas. So we want to calculate the area of the following shapes. So the first one is a triangle. It doesn't matter that it's kind of upside down. The base is 60 and the height is 60. So the area would be base times height divided by 2, a base of 60 centimeters times a height that's also 60 centimeters divided by 2. Order of operations say that we would calculate the top first and then divide by 2 second. So 60 times 60 is 3,600. Divided by 2 would be 1,800. And area is always in units squared. So it would be 1,800 centimeters squared. So what that means, if you took small squares that measured 1 centimeter by 1 centimeter, it would take 1,800 of them to fill up that shape. That's what it means. Obviously, it's not drawn to scale. 60 centimeters would be a lot larger than what the picture shows. But that's what it means. If you had small squares that measure 1 centimeter by 1 centimeter, it would take 1,800 of them to cover up that shape. The next one is a rectangle, and the formula for area of a rectangle is length times width. So we have a length of 8 feet times a width of 4 feet. 8 times 4 is 32, and again, remember that area is always in units squared. So that'd be 32 feet squared or 32 square feet. The next one is a square. So each side would be 5 inches long. And the formula for area of a square is S squared, where S represents the length of one side, or each side. Not only are you squaring the 5, but you're also squaring the inches. So you're going to get 25 inches squared. So again, if you had small squares that measured 1 centimeter by 1 centimeter, it would take 25 of them to cover up that shape. The last one is a circle, and the formula for area of a circle is pi r squared. And the reason they use the approximately equals symbol there is because, again, pi is an irrational number. We're going to get an answer that's going to be a non-repeating, non-terminating decimal. We're going to have to round it, and that's why it's an approximate. So again, pi is a constant, the value that never changes. But that needs to be multiplied by 6 centimeters. That needs to be squared, because the formula is pi times the radius squared. And the radius of that circle is 6 centimeters. So again, this is what pi is. Most calculators have a pi button on them. But that's only part of it, because that decimal continues on forever and ever. It never stops, it never repeats. And that's going to be multiplied by 6 squared. Your calculator will do order of operations. It'll square the 6 first and then multiply. And so when you round that off, I'm going to round it to the nearest tenth. It'll be 113.1 centimeters squared. So again, not only are you squaring the number, you're also squaring the centimeters. 113.1 centimeters squared. All right, so this next one says determine possible dimensions for each area, then use the dimensions to calculate the area. Well, in this case here, you are given that the area of a rectangle is 6,400 meters squared. Area of a rectangle is found by multiplying length times width. So you need to find two numbers that multiply together to get 6,400, and they should be fairly close together, because you could say one possible set of numbers might be 1 meter by 6,400 meters. They multiply to get 6,400 meters squared, but that would mean that the one dimension is way bigger than the other. You could say it's 2 times 3,200 meters squared, but again, that would tell us that one dimension is way bigger than the other. So you just want to find two numbers that multiply together to get 6,400, and they should be fairly close together. So just looking at that, I think 64 and 100 would work. They're not too far apart, and they multiply together to get 6,400, which is in fact the answer that that they have there. If they do the length of 100 meters and a width of 64 meters, they multiply together to get 6,400 square meters. And those two numbers, excuse me, are fairly close together. Now this next one is a square. And remember that the area of a square is the length of one side squared. We're given the area, and that's supposed to be 225. Just can't see that last number. So the area is 225 square feet. So S squared will equal 225 feet squared. And we've done this earlier. If we take the square root of both sides, because we want to know what S is, not what S squared is, and the opposite of squaring is square rooting, the square root of 225 is 15, and the square root of feet squared is feet. On the right side, the square root of s squared is s. So there's the answer for that one. That is the missing dimension. That's the length of each side of that square, 15 feet. Now, the other thing it asks us to do is to convert those dimensions into another area. So for the first one, the dimensions are 64 meters by 100 meters, and they want to know how many square kilometers that is. How many square kilometers is 6,400 square meters, Princess? Is it inches or centimeters? That was the question. Huh? No, that wasn't the question. There was no question. I know. Okay, so we want to convert 6,400 meters squared into kilometers squared. So you might remember that to go from meters to kilometers, you divide by 1,000. So we learned that before. It was on that metric staircase. If you took the 6,400 and divided by 1,000, that would give you 6.4 square kilometers. Okay? But what if we took the original dimensions and converted them into kilometers first? So 100 meters, if you divide that by 1,000, would be 0.1 kilometers. And 64 meters, if you divide that by 1,000, would be 0.064 kilometers. 0.064 kilometers. And if you took those two numbers and multiplied them together, 0.1 times 0.064, that gives us 0.0064 kilometers squared. Okay? Cheney? Yes or no? Stay with us, okay? And if we check, that is what the correct answer is. So, going back, we said if we started with 6,400 meters squared and we just divided that by 1,000, we got 6.4 kilometers squared. But that's not the right answer. The answer should be 0.0064, which is what we got if we took each of the dimensions and converted them into kilometers first and then multiplied them. So here's the thing. If you want to go from meters to kilometers, yes, you divide by 1,000. But if you want to go from meters squared to kilometers squared, you actually have to divide by 1,000 squared because area is unit squared. So 6,400 meters squared, try that again, 6,400 meters squared, to convert that into kilometers squared, you'd have to divide by 1,000 squared because area is in units squared. So let's check that one on our calculator and see if we get the right answer. 6,400, which was the square meters, divided by 1,000 squared does give us the right answer. So that's how you go from meter squared to kilometer squared. You have to divide by 1,000 squared because there are 1,000 meters in a kilometer, but also the squared part comes from the fact that area is in units squared. Whoops, 0, 0. I missed 1 0 there. All right, so if we apply that same thing for the next one, the side length was 15 feet, and that was 225 square feet. And we want to convert that into square inches. So to go from feet to inches, you multiply by 12. But if we want to go from feet squared to inches squared, if we follow the same logic as the previous question, we'd have to multiply by not just 12, but 12 squared. So it should be 225 times 12 squared, because we're going from square feet to square inches. There are 12 inches in a foot. If it was just feet to inches, you'd multiply by 12. But now we're going from square feet to square inches, so we have to multiply by 12 squared. So let's do that and check and see if we get the right answer. So 225 times 12 squared is 32,400. And if we take our magnifying glass, that is the right answer. To go from square feet to square inches, you have to multiply by 12 squared. And that will give you the right answer. Okay? So this example on the next page, an art class is creating a mural mosaic. They know that future art classes will have to contribute to the project to complete it. Each person in the class paints a painting on a 15 centimeter by 15 centimeter panel. Then all the panels are assembled into the mural mosaic. There are 25 students in the art class. So the panels they create will be assembled into a square with each side containing 5 panels. What area is required for this part of the mural? So each person will make a painting on a 15 centimeter by 15 centimeter panel. And they're going to put them together with 25 students. So now you're going to get a shape that is 5 panels by 5 panels. So the dimensions of each side would be 5 panels times 15 centimeters per panel. 5 panels times 15 centimeters per panel, which should be 75 centimeters, I think. 5 times 15, yes. So it'll be 75 centimeters by 75 centimeters. That will be the dimensions of that mural mosaic. And if you go 75 times 75, that's 5,625 centimeters squared. And that's all it asks us to do for that. Okay. If we wanted to convert it into square meters, to go from centimeters to meters, you would divide by 100. But if we want to go from centimeters squared to meters squared, we would have to divide by 100 squared. And that would convert it into square meters. So divide by 100 squared would be 0.5625 meters squared. So looking at those questions below, determine the area of a rectangle that is 1.7 meters by 2.5 meters in square centimeters. So there'd be 2 ways you could do this. The first way would be to convert the dimensions first from meters to centimeters and then find the area. So this would be solution 1. 1.7 meters times 100 will be 170 centimeters. 2.5 meters, again, to convert from meters to centimeters, we multiply by 100. That would be 250 centimeters. And then the area would be found by multiplying these 2 numbers together. So 170 times 250. So this is one way to get our answer in centimeters squared, 42,500. The other way to do it, though, would be to take your dimensions and find your area in square meters by going 1.7 by 2.5. That's 4.25 meters squared. And then if you wanted to convert that into centimeters squared, you'd have to multiply by 100 squared. If we take that number and multiply by 100 squared, you get the same answer, 42,500. Both methods work. The difference is that the second method, you only have to do one conversion, whereas the first method, we had to do two conversions. The first method, we did two conversions, then found the area. The second method, we found the area first and did one conversion. They both work. So it doesn't matter which way it's done. Part B, determine the area of a rectangle that is 50 millimeters by 25 millimeters in square meters. So I'm going to do this one by finding the area first. So I only have to do one conversion. 50 times 25, I think, is 12,500. No, 1,250. Yeah, 1,250 millimeters squared. And now if you want to go from millimeters squared to meters squared, you'd have to divide by 1,000 squared. To go from millimeters to meters, we divide by 1,000. But to go from millimeters squared to meters squared, we'd have to divide by 1,000 squared, because there are 1,000 millimeters in a meter. So it's 0.00125. And that would be in meters squared. So again, you could have taken the two numbers, original numbers, and converted them to meters by dividing by 1,000. So it'd be 0.05 times 0.025. You get the same answer if you convert each of those to meters first. So again, both ways work. Tiles imported from different countries sometimes have imperial dimensions. A tile layer may need to convert from square feet to square centimeters. One type of floor tiles is sold in squares measuring 1 foot by 1 foot. What is the area of one tile in square centimeters? So I'm going to do this by only doing one conversion. The area of the tile is 1 foot by 1 foot. And 1 times 1 is still 1, but it's going to be 1 square foot when you find the area. And now from there, we want to convert to square centimeters. If you look on your formula sheet, Jan, to go from feet to centimeters, if you look on your formula sheet, what does it say, Brock?
30.
Yeah, what Princess said. It's 30.48 centimeters in a foot. So if you want to go from feet to centimeters, you'd multiply by 30.48. So how do we go from feet squared to centimeters squared, Ava? Janie? Good, yes. Because we're talking about area. Now, 1 times anything is just that anything, right? So really, the only thing we have to do here is just times or find out what 30.48 squared is. Because you're just going to multiply that by 1. So there's the answer. I think it says to the nearest No, it doesn't tell us what to round it to. It just says in square centimeters. So let's round it to 1 decimal, or let's say 2 decimals. Or I guess we could just write down the entire number because it's only 4 decimals. 929.0304. And that would be in centimeters squared. Part B says the tile layer is working with an area that measures 8 feet by 4 feet. What is the area of this to the nearest hundredth of a square centimeter, and then also to the nearest square meter? So if we take 8 feet by 4 feet, that'll give us 32 square feet. And we have seen that if you want to convert from square feet to square centimeters, you need to multiply by 30.48 squared. So that's what we will do. We'll multiply 32 by 30.48 squared. And so it's a big number, 29,728.97 to the nearest hundredth. That's 2 decimal places. So 29,728.97. Centimeters squared. And if you want to convert that to the nearest square meter, to go from centimeters to meters, you divide by 100. So to go from centimeters squared to meters squared, Liam, what do we do? Yeah, divide by 100 squared, which is 10,000. It's got to have 4 zeros, but you can just divide by 100 squared. So to the nearest square meter, it would be approximately 3 square meters. 2.97, and there's more decimals there. But to the nearest square meter, it's approximately 3 meters squared. Okay? So we're going to be talking about volume next, but volume is what fits inside of an object. You can only calculate volume if it's 3-dimensional. So far with area, that's just 2-dimensional. You can draw it on a page. But volume is what fits inside of something. And so that's 3-dimensional. So you've got this moving truck, and you've got the dimensions, and we want to find the volume. Well, this is a box or a prism. And if you look on the formula sheet, it says that the volume of a prism is B times H, where B is the area of the base. The base is a rectangle. And the area of a rectangle is length times width times H, which is height. So essentially, we're going to use the formula for volume of a box as length times width times height. So you just multiply these two numbers, or 3 numbers, together. 3.5 meters times 2.3 meters times 2.2 meters. So 3.5 times 2.3 times 2.2. There's the answer, 17.71. Now remember, area was units squared because you multiplied 2 units together. Volume, though, is units cubed because you're multiplying 3 measurements together. So it'd be 17.71 meters cubed, or cubic meters. So here's what that means, all right? If you had little boxes, 3-dimensional boxes that measure 1 meter by 1 meter by 1 meter, 1 meter high, 1 meter wide, 1 meter long, it would take 17.71 of them to fill up that moving truck. That's what that means. It's 17.71 cubic meters, which means it would take 17.71 small cubes that measure 1 meter by 1 meter by 1 meter to fill up that space. Okay, so I will Mark the assignment down here that you should work on for practice. I will post the solutions to Google Classroom so that you can check your answers. I would encourage you to do the practice though, because it's going to help you when it comes time for your quizzes and your tests. So I will post the solutions to Google Classroom. Remember, it's only about 2 weeks left now till all your assignments are due. So if you have stuff that needs to be done, you need to get working on it, get it in, because on the 9th, anything handed in after that, well, I won't take anything after that. It's zero. So you need to start working on any of your assignments that you have missing. Don't leave it till the very end, because some of you will be just too much for you to get it all done. But when those zeros go in, your marks will go down. All right, so you need to clear your desks for your quiz. I will give you a clean